Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to talk about graphing functions using transformations. The first thing I'm going to show you guys today is what's called the library of functions. I'm putting up not every function in existence, but very popular functions that you are going to see throughout this year and throughout your other math courses as you continue on the educational process. I'm going to describe each of these functions, going to show you the domain and range for them, and then we're going to learn how to transform these parent functions. Every function I'm going to show you here is called a parent function. A parent function is the most basic root of a function. Okay, it's the parent. Once you have the parent function, you can shift that function. You can make it wider, narrower. You could shift it up or down, and you can shift it left or right. Those are all called transformations. But before the transformations can really help you out, you have to at least know the basic form of a function. So the first function we have here, it's called an identity function. It's also called linear because when x has an exponent of 1, remember there's an invisible 1 here, that is a linear function. We know how to graph linear functions already, y equals mx plus b. And the parent function here is just simply f of x equals x. Remember that f of x is a fancy way of saying y. So y equals x. The domain, since it keeps going on forever to the right and to the left, it's all real numbers. And since it keeps going up little by little and down little by little, it's all real numbers. Next, the square function. Sometimes they call this a quadratic function. It's quadratic because x is squared. Okay? When x is squared and you have a quadratic function, you have what's called a U-shaped graph. The domain of this particular parent function is all real numbers because little by little you're going further to the left, little by little you're going further to the right. And your range, though, your range of the possible y values. Your range, the lowest point is right here at x equals 0. So your range goes from 0 all the way up. So it's from 0 to positive infinity. Cubic function or cube function. Sometimes they call it cubic. It's called cubic because x is raised to the third power. It's cubed. If you can see, this has a form here, it's a little squiggly line, and that is the form of the parent function. The domain and the range here are both all real numbers. They go from negative infinity to positive infinity. Okay? Next, we have what's called a reciprocal function. Sometimes these are also called rational functions. Why are they rational? Because x is in the denominator. In this particular case, you have two separate sides or parts of the graph. Okay? And this is the format of this graph. The domain here is from negative infinity to 0, okay, because it's going to the left forever, but it stops right here at 0. So it cannot go further. But then it's in union with, it's going to the right forever. So from 0 to positive infinity. The range, though, since it goes up forever and it goes down forever, actually this is wrong. The range is the same as the domain here. I'm going to have to fix that. That is my error. Scratch that range off. That is inaccurate. Because it goes from negative infinity all the way to the 0, and then it goes from the 0 all the way to positive infinity. So the domain and range are both from negative infinity to 0 in union with 0 to positive infinity. You have a square root function. Bless you. It's a square root function because x is inside of a square root. The domain here is from 0 to positive infinity because it's going to the right forever, but it stops here at 0. And the range is also from 0 to positive infinity because my lowest y value is 0 and it's going up little by little to positive infinity. You have a cube root function. A cube root function is a cube root function because the variable x is inside of a cube root. The domain of a cube root and the range of a cube root are both negative infinity to positive infinity. Okay. Now, the linear function, we kind of already saw it. It's an identity. So actually, I don't know why I put it there again. It's pretty much the same as number 1, so we're going to skip that. A constant function. Remember that a constant function looks like this. This is a y equals equation. Y equals a. The slope of this is 0. We know this. The domain is all real numbers from negative infinity to positive infinity. And the range is literally just the y point. So in this particular case, this is a y equals 3 equation. My range would be y equals 3 because that is the only y value that is valid throughout this function. Absolute value function, we saw it already last week. Absolute value function, and I don't know why I didn't put the actual function, is a y equals absolute value of x. And the domain is from negative infinity to positive infinity. The range is from 0 to positive infinity. All of these graphs, you're going to have to memorize the shape of them. You're going to have to memorize what they look like. Because when we shift them, if you don't know that, it's going to be very difficult for you. So let's talk about these transformations. Yes, sir. No, if it's an x equals equation, then it goes like this, and that is not a function. Because here you're going to have several different y values for the same x. So no, that is why an x equals equation is not here, because it is not a function. Thank you for caring. Good man. May I continue, my brothers? Okay. Now, let's look at a quadratic parent. Y equals ax squared. The way you graph any function, okay, the easiest, most basic way is to make a table of values. Now, you don't need to use the moral 5 if you know the shape of your parent function. All you need is 3 points. Negative 1, 0, and 1. If x is negative 1, okay, y is 1. If x is 0, y is 0. If x is 1, y is 1. So I got 0, 0, 1, 1, negative 1, 1. I know it's a U-shaped graph. And that's pretty much the nice, easy way to graph a quadratic function. Okay, that's the parent. Now, I can shift this up, down, left, right, and I can make it narrower or thicker. Not only for this quadratic function, but for all of the functions that I just finished showing you in the previous page. How? When we have it in what's called a vertex form. You can put any of the functions that we talked about in what's called a vertex form. Okay? Vertex form has 3 key ingredients to it that make it powerful. All right? You have the A, which we're going to talk about all of these in detail. But the A is going to determine if it goes up or down, and it's going to determine how wide or how narrow it is. That's what the A will do. The H, first of all, it's always opposite. And the H is going to determine whether it goes left or right. And then you have your K. And your K is going to determine whether or not the whole function itself goes up or down. A determines if it points up or down, but K determines if the graph is shifted up or down. Notice that the H is encapsulated always with the X. Notice that the K is always separate from the X. It is outside of the parentheses. This is something you guys really got to understand and learn forever. This is going to haunt you or help you forever for the rest of your math career. So let's talk about in detail this A, H, and K. Okay, the A is very important when analyzing a quadratic function. If A is greater than 0, then it points upwards. So I know that if I have, for example, let's say, just to make life easy, y equals x squared. Negative 1, 0, 1, 1, 0, 1. I know that it's going to point upwards. Not only because my points tell me so, but because my A here is greater than 0. There's an invisible 1 here. Try to remember that. So as long as it's positive, I am pointing upwards. As long as it's positive, I am pointing upwards. So if you graph a quadratic or any other function, and your A is negative, and your graph is pointing upwards, you made a mistake, my brothers. It's that simple. If A is less than 0 and it's negative, you're going to have a function that points downwards. So for example, let's say it was y equals negative x squared. Okay? When x is negative 1 squared is 1 times a negative is negative 1. 0, 0, 1 squared is 1 times a negative is negative 1. So I've got 0, 0, 1, negative 1, negative 1, negative 1, and my graph points downwards. If you have a negative A and you graph it and it's pointing upwards, you made an error, my brothers. That's all. No big deal. Erase it. Start over. So again, if A is positive, it points upwards, regardless of the graph. Think about the linear equations that we did. When x is negative, doesn't it go down from left to right? Okay, so if A is positive, it points upwards. If it's negative, it points downwards. Does that make sense? Yes, sir. For this quadratic function, it will be a U shape always. Yes, sir, my brother. Because it's quadratic. Every function, like I just finished showing you, has its own particular shape. And that shape will always stay. Whether it's going up or down, if it got narrow, if it got wider, if it shifted to the right or to the left, it's still going to be that shape forever. Thank you, my brother. Okay, what else about the A? Okay. Regardless of whether or not the A is positive or negative, the positive or negative tells you if it goes up or down. But if the absolute value of A is greater than 1, then you have what's called a vertical stretch. The larger the absolute value of A, the more narrow it becomes. Let me show you how it works. Hopefully by now, you know that the parent function for y equals x squared is 0, 0, 1, 1, and negative 1, 1. Let's see the difference when it's y equals 2x squared. Well, in this case, negative 1, 0, and 1. When x is negative 1 squared is 1. 1 times 2 is 2. 0, 0. When x is 1 squared is 1 times 2 is 2. So I've got 0, 0, 1, 2, negative 1, 2. And do you guys see how it is narrower? Pretty cool, right? The larger the absolute value of A, the more narrow the graph becomes. It's called a vertical stretch. I apologize for everyone out in the internet world. You cannot see this, but think about a rubber band, okay? When you have a vertical stretch, you're going up. Isn't that become more narrow? That's what a vertical stretch is. So everyone out there in the internet world, get a rubber band and just pull up on it. You're going to see it becomes a lot more narrow. That's a vertical stretch. Now, if the absolute value of A, regardless of if it's positive or negative, that's why it's absolute value, is between 0 and 1, in other words, if it's a fraction or a decimal, okay, you're going to have what's called a vertical compression. Vertical compression. That means it's going to become wider. Again, let's graph my y equals x squared. It's 0, 0, 1, 1, negative 1, 1. And that's my graph. I didn't like that. 1, 1, negative 1, 1. And that's my graph. Now, if I have y equals 1/2 x squared, it becomes a little bit different. First of all, what do you guys remember whenever you make tables? What do you do when you have a fraction in front of the x? What do you use? What do you use? No, we're not solving for x here, boys. We're trying to find a value. Thank you, sir. You're going to use multiples of the denominator. So I'm going to use negative 2, 0, and 2. Negative 2 squared is 4. 4 times 1/2 is 2. 0, 0. When x is 2, 2 squared is 4. 4 times 1/2 is 2. So this is 0, 0, 2, 2, bless you, and negative 2, 2. And do you see, gentlemen, how that becomes wider? So A, again, if it's greater than 0, the graph must point upwards. If it's less than 0, it's a negative, the graph must point downwards. If the absolute value of A is greater than 1, the larger it gets, the more narrow it gets. If the absolute value of A is between 0 and 1, that means it's a fraction or a decimal. That means that it's going to get wider. You with me here? Thank you. Okay, the H. If the H is positive, guys, that means the graph will shift to the left. If it's negative, it means it shifts to the right. Why? Because you have this x minus thing here. So if I saw x minus 3, what's the real value of H here, guys? 3. If I saw x plus 3, what's the real value of x here? Negative 3. So you always go opposite. So how does this work? Okay, my parent function again, 0, 0, 1, 1, negative 1, 1. Now, I can go ahead and make a table of values if I want to find the new points, or I could use the power of transformation. H shifts the graph left or right. When I have a negative here, I go to the right. When I have a positive, I go to the left. So I have x plus 3 here, right? So literally, guys, pay attention. You literally go 1, 2, 3 to the left, 1, 2, 3 to the left, 1, 2, 3 to the left. Should have done that in green. And this will be my new graph. Same width, pointing the same way. It just got shifted every single point to the left. It's that simple. As long as you know your parent. The parent function is key here. That first page is really more important than anything else today. This is easy, learning how to shift. Learning the functions, it's easy, but it takes some time. If H is negative, my brothers, keep both of them, then you're going to shift to the right as many places as are there. So again, let's graph my parent function, 0, 0, 1, 1, negative 1, 1. That's my graph right there. Now I have y equals x minus 3 squared. So that means you got to go to the right 3 units. So that means every single point gets shifted to the right. 1, 2, 3. 1, 2, 3, and 1, 2, 3. And my graph, I didn't like that. And my graph, let's see, let's do this here again. 1, 2, 3, and then 1, 2, 3. My graph got shifted 3 points to the right. So as long as you know your parent function, that's all you got to graph, and then you just shift. It's making sense so far, my brothers. It's not that bad, right? You guys have seen this before, right? And you weren't too happy about it before, were you? This isn't as bad as you thought, though, is it? Okay. The K. The K is going to shift the graph up or down. There's no opposites here. If the K is positive, I shift up that many units. If it's negative, I shift down that many units. So once again, let's graph my parent function. Y equals x squared. 0, 0, 1, 1, 1, negative 1. That's my graph. But I'm shifting this 2 units up. So that means every single point goes up 2 units. So I go up 1, 2, up 1, 2, up 1, 2, and that is my graph shifted up. Not bad, right? And last but not least, if it's negative, it shifts downwards. So, again, my parent function, 0, 0, 1, 1, negative 1, 1. That's my parent function of my quadratic. But I got a x squared minus 2, so I shift down 2 spaces. I go down 1, 2, down 1, 2, down 1, 2. Should have done it in green. And that is my graph shifted. Are there any questions about the A, the H, or the K, my brothers? Promise? May I continue? Correct. They're just telling you exactly how to shift. That's exactly right. These are directions on how to shift. That's exactly correct, my brother. Well put. I like that. Good job. Does that make sense, gentlemen? Okay. Let us continue then. Now, how do I graph this? Okay. There's a couple schools of thought here, okay? One way to do this is, well, you know what? Wait, that's the easier way. Let me show you another way. I'm not going to, this is not my favorite way. This is not how I want to do it, but I want to show you how you put everything together. Let's say that you have y equals negative 2x minus 3 squared plus 2. A lot of people will just start using the moral 5 and they'll start plugging in numbers and it's going to be forever. Maybe you get the U shape, maybe you don't. You get frustrated. You mess up on one negative, you're out of luck, it's all wrong. All your time, your effort has been thrown away. So if you get this, I'm going to show you 2 ways today. You can first off graph the parent. And if it's squared, that means that your parent in this case is y equals ax squared. So you make a little table. X and y, negative 1, 0, and 1. Okay? Your parent in this case is y equals a, which is negative 2x squared. Is everyone with me? Guys? If x is negative 1, what's y? Negative 2. Okay, good job. Negative 1 squared is 1. 1 times negative 2 is negative 2. Great job. If x is 0, what's y? If x is 1, what's y? Negative 2. Okay. So now, from there, we graph it. We're going to graph the parent. So let's graph the parent. -1, -2, 0, 0, 1, -2. That's my parent function. Why is it a little narrower than the other ones we saw? Yes, sir, my brother. My A is an absolute value of 2. Good job. Why is it pointing downwards? Sir, because it's a negative. Very good. So that's my parent, guys. But now I got to throw in this shift here. So how am I going to shift this graph? Yes, sir. 3 to the right and up 2. So literally you go 1, 2, 3, up 1, 2. 1, 2, 3, up 1, 2. 1, 2, 3, up 1, 2. And that is the graph of my function. Be honest. It's pretty easy, isn't it? Okay, that's hard compared to what I'm going to show you now. That's a joke, and that's hard compared to what I'm going to show you now. Sir, my brother. No, not a rise over run at all. At all. No. H shifts it to the right or to the left, and the K shifts it up or down. So from this point to this point, I went to the right 3 and up 2. A slope would indicate, sir, that it's constant throughout the line. You have a slope with absolute values or with linear equations. But with a function that curves, there is no slope. I went from this point to this point by doing 1, 2, 3 to the right, up 1, 2. I went from this point to this point by going 1, 2, 3, up 1, 2. So this is one way to graph any function. Graph the parent, shift it. Not bad, right? This is difficult in my opinion compared to this. This shifting H and K represent what's called the vertex. Didn't we learn about the vertex with absolute value? That's my HK. So guys, I think this is going to make your life a lot easier. Number 1, find and graph your HK, which in this case would be -2, 1. Why is the H opposite? Because it's always opposite. Number 2, find and graph the y-intercept. The y-intercept, hopefully you remember from linear equations, is the y value when x is 0. Step 3, if the vertex and the y-intercept are the same ordered pair, plug in any value for x and find the corresponding y value. Then graph the ordered pair you found along with its mirror image. Or you can solve for the x-intercept, which we don't know how to do yet. So, let's talk about this. I have y equals x plus 2 squared plus 1. You go ahead and bring that bad boy down. Let me show you how beautiful this is. Step 1, find your vertex. My vertex is -2, 1. So that's my vertex. Step 2, what's my y-intercept here? When x is 0, if this is 0, what's 2 squared? Plus 1? Okay. 1, 2, 3, 4, 5. Now, on your vertex, guys, there's an imaginary line that's called an axis of symmetry. This axis of symmetry is the line that cuts the graph into perfect halves. So if you fold the graph along the axis of symmetry, every single point from the right side of the graph will intersect with every single point of the left side of the graph. So this is what makes life easier. I call this the mirror image point. If my y-intercept is at this level, 2 to the right of the axis of symmetry, where do you think the mirror image would be? 2 to the left, 1, 2. Guess what? You're done, guys. You've graphed your quadratic function. Tell me that's not easier. You don't have to shift. You don't have to do anything. But you do have to be able to recognize, okay, this shifted the original graph 2 to the left and up 1. All you got to do is find your vertex, Your y-intercept, graph the mirror image. Now, again, this is the important part. If your mirror image, or I'm sorry, if your y-intercept is the same as your vertex, you have to make just one table of value, just for one value. Just for one value. And I think I have an example. No, I don't, but I'm going to give you an example right now. Does this make sense here? Promise? Okay. Real quick then, last thing before I let you guys go. Let's say I have y equals, excuse me, okay, this is a good one. Let's say I have y equals x squared, I don't know, minus 3, okay? In this particular case, gentlemen, in this particular case, what's my vertex? 0, negative 3. So I graph it, 0, negative 3. In this particular case, what's my y-intercept? 0, negative 3. Uh-oh. We have the same exact point for the vertex and the y-intercept. I need another point, though. I need one more. So literally, just make a table of values for just one x value. What x value do you want to use? Because I don't care. Okay, using 0 wouldn't be wise because 0 is already here. How about we use 1? Keep it simple. 1 squared is 1, minus 3 is negative 2. So you got 1, negative 2, mirror image, 1 to the right, go 1 to the left. Guess what? You just graphed your quadratic equation. It's pretty boss, right? Guys, thank you so much. I know it was a long lesson today. Thank you for your patience, for your questions. I hope you learned a lot. Have a wonderful day, and thank you.